Hey guys, welcome back to another video, and in this video I'll be showing you how to actually make a case for your project and prototypes. So as I did for mine, and as one of my subscriber asked for it in the comment section, so I thought that why not to make an actual video on it. So yeah, here it is. We'll probably gonna be going through some steps and procedure in the video, and I think that there might be some complexity and difficulty throughout the process, but I mean, we all are engineers by birth, so we're probably gonna do it. So let's get started. So in order to carry out a case like this for your project, you actually need 2-3 steps. That the first step is to get actual CAD software, second is 3D printer, and third is the most important, actually getting it done. So the first is CAD software. For my case, I actually use Solidworks for uh, designing the case and everything, and I think that the software isn't free and you need license for it, but you can actually get student license or maybe just steal it from any website. So probably don't do that, but uh, the next thing is to actually design the casing on SolidWorks. Let's do that. But how do you even get the measurements and everything? So for getting the measurements for your project, I actually used scale and pencil, and that's it, and pen and paper, and that's it. So the main thing is to get the measurements first. You're going to do it manually because uh, vernier caliper is not available to me, so maybe not to you too, so do it manually. And after getting the measurements, it should probably look like this. My handwriting and drawing isn't that good, so please ignore, and you'll probably gonna go with something like this. And the next thing is, after you get all of the measurements and everything, the most important step is to leave some room for error and some better space. And because I made this mistake, so that's why I'm here to tell you that. Because you see here, my type C and my aux cable is fighting for space, so that's why uh, probably don't do that mistake. And if you are able to buy a vernier caliper, please do, because it's much higher in precision and measuring. My flatmate my flatmates all sucks, but still I let it pass. So now the next step is to actually get some measurements done, and then we'll jump to SolidWorks. So in order to actually carry out this, I took the case of on how many sides do I want to cover. So I wanted this sides and the bottom side to be covered, so that's why it was 5 sides, 5 faces. Maybe sides is the wrong word, and maybe you'll need 5 faces for your case, and that's how it will actually look. And then you're probably going to mark up all the measurements, and then we'll move ahead with SolidWorks. Okay, so obviously you're gonna need SolidWorks or any CAD software for designing your case, or any open source software. But in my case, I'm using SolidWorks because it's free for me, given by the college. So we're gonna go to the parts, and it's actually quite similar for most of the CAD softwares to actually design something, but let me just show you how I actually did it. So it's just basic sketching, and you'll probably gonna go here, and then so now I'm going to fast forward the video a little bit, but I'm going to explain it in the middle, so probably just watch it. So first we'll start by actually making some shape. So in my case, I made a rectangular shape, so and this is how it is turned out to be. And we need to close the shape first, and then we're going to make the measurements pretty much clear. So in order to actually design the case, there are many things that you need to learn in between. So we need to add constraints to our shape so that it is actually going to close that, and then we're going to do this, then we're going to do this, and then it's kind of fixed, but no. So this is how it is, the basic idea. So in order to get the right dimensions, we need to go on smart dimension and then do this, and this will actually ask you that what is the length of the side that you are actually going to need. So in my case I needed 10.8 centimeters, which is 108 in millimeters. So that's going to be 108. So this is 108, and then this is going to be 52 because I needed 5.2 centimeters. So this is also done. And then if we see this is the basic of what we are actually going to need, and then it's going to get a little complex, but you'll probably get it. You need a center line. Okay, so we are done with this part and making the bottom side or bottom face of the case, and this is how it actually looks. And you are done with the first one, and you need to make the 4 of it just like this. And we are just going to do the final step, which is making it a layer. Okay, so we got the first one, and it turns out to be the same as this one at the bottom. So this is the same as this one, and I have just carved a hole for the button, and you are going to actually 3D print it, and then we are done with the first one. Make sure that your sketch should be actually fully defined. If it's not fully defined, it will probably show at the bottom, and if it's not fully defined, then you won't be able to print. Now for actually making this file for STL, that is the 3D printer file, which we're gonna need for actually 3D printing it, we have to go here and save it, and just go through this and look for STL file and save this as part 1 tutorial. Okay, so it's done, that's it. And now you're probably going to need the other 4 sides of the same what we have done here. It's not a different thing, just make sure the dimensions are proper, and you just do the same process that I did. Now we're probably going to close Solidworks. Okay, so now our Solidworks part is over, and congratulations, you made yourself a casing for it. And now make it real life. So we'll go to the 3D printing part now. So we are done with designing the first part, and you'll probably going to need the 4 of the parts just like this, and you'll be done with designing the first thing, which is doing the Solidworks job. Now our next thing is to go with the 3D printing. Now we have the basic STL file, which is the basic file needed for 3D printing, and now we're probably going to need a 3D printer. Obviously I used my university's 3D printer. I don't have one. I don't have that much money right now to buy a 3D printer, but according to your use, you can use any 3D printer which is available. I mean, there are many 3D printers which are available for rent too, which can do your job. but if you already have a 3D printer, you can convert the STL file to actually whatever the file is needed for your 3D printer. I mean, at my home I had a 3D printer which was using G-code file, so I transferred my STL file to G-code file and then 3D printed that. So for my university, I just sent them the STL file and they printed out. So now I'm going to show you the next step, which is actually making the plate of the 3D printer and how it turns out to be on the 3D printer's plate. For this, I'm using a reference of Anycubic slicer, which is again a open source software, but I had this software for my 3D printer which is at my home, and I'm obviously not having that 3D printer right now here in the UK, but because I'm poor. And the next thing is to place all the STL parts from the Solidworks to 3D printer's plate. Now let's do that. Now we'll probably open Anycubic slicer, and this opens a little late because it takes time to load and not remind, and this is how it will actually look. And it's quite easy to operate all of these softwares. I mean, not SolidWorks exactly, because SolidWorks is just okay. So this will be shown on your slicer or maybe whatever software you're using for your 3D printer, but we're going to go to import and then part 1 tutorial, and then how easily that is imported. And now we want it to go horizontally, not vertically, so we'll change the rotation by 90 degrees. And that's it, it's done. So that's how you actually place your part on the printer's plate, and you can duplicate it or maybe cut it or whatever you need, but that's how I actually did. And let's just import other files too from what we actually designed. Okay, so congratulations, it's done. From looking like this to this, it's actually done. And next thing is to just 3D print it. That's probably going to take 2-3 hours, that's it. With just a little more speed, you can get it done in like 1.5 hours maybe. And just paint it up, because my casing was white color and I painted it with black color. And for next step is, okay, so you are done with the 3D printing too. Now what to do? So you'll probably get all the parts that you needed, and now just paint it up. I painted black because black supremacy. And the next and the final part is to cut out the buttons and space what you need for charging port and everything. So what I did is I measured it from scale again. I actually, before painting it with color, I actually used scale and pencil, and just made sure that the project, that the main body is actually fitting in with the case. And I actually made some markings and precisions that it was fitting with, and with that I was able to get the right shape. And make sure that you leave some extra space, because you might get some error like this. my aux cable has more than extra space, and my type C cable too for charging, because I effed up. So that's the thing, you have to leave some extra space for it. And same with the casing and everything with the measurements, you have to leave some extra space so you can get some tolerance. And just for the prototype and version and casing, this is what it will be turning out. And I think that's what you all needed, right? Just one subscriber. I mean, but this video might reach to many of the people out there who are trying to get their casing done with for their projects and their prototypes, but I think that they might be able to get better precision by using like much better equipments. I used scale here. They can use vernier caliper for better precision, and also they can use a much better 3D printer. My 3D printer from the university sucks because it's not the best, but they can obviously get the right measurement and much more better results than mine, what it turned out to be. But still, mine works and it turned out pretty much better. So that's it for the video, and make sure you like, subscribe and share, and that's it. And also, my next project video is actually little delayed because I made up a mess, and the microcontroller board is actually fried in this, and it was going to be a really nice project, but yeah, I made a big mistake here, and now I don't have money. I'm poor. So help me guys and subscribe my channel, and so that I can make much more project videos. And I'll probably gonna borrow some microcontroller boards from my university. Those sucks, but we'll get the job done. So subscribe, and I'll see you in the next one. Bye.